Okay, once you got a permission, you need to check whether API is working correctly. Let's give a base URL. You need to give some parameters and paste it. And data type should be JSON, and base date format should be year, month, and date. And you give the base time 6 p.m. in Korean time, so send the request. Oh, sorry, we need to also specify the x coordinate and y coordinate. Send the request. Status is 200, okay, which means it succeeded. And when you see the response, you can see the header and normal service, and within the body and items, and you can see the readings from this weather sensor, the category and values here, so all different. This is correct. So import request datetime and time delta. And first we need to define base URL. We need to specify the parameters. This time we are not just gonna use the static value, we actually need to give a value from the function. We're gonna call the time zone. We're gonna call datetime now function, which awares Korea time zone. Once we got the datetime now object, we got the date and time, and we provide this to the parameters. Once you set the base URL and parameters, you need to call API using request. After we save it, we need to transform to the JSON object. We also assign JSON response JSON. Using this one, we need to transform it to pandas data frame. To do that, we need to get the key response, and within the response object we have body, we have items, inside of the item we have item. Let's see, data frame, and we can give this to the PD. What we're gonna do is a pivot, and we need to give an index. Let's try base time, and columns corresponding value should be observed value. Let's try. We save as tf pivot. Also, we need to handle those 4 columns which have same value across the row. What we're gonna do is subsetting, drop, duplicate. We got only one row, we assign to df left variable, and we're gonna merge these 2 tables. This is the final version we want to store to the Postgres. So basically, the DAG is a collection of tasks. Directed, a cyclic graph. Directed means there are order of execution. A cyclic means once you reach end of the task, you are not coming back to the first one. And graph means the task and the dependencies are forming a graph structure. Task, we have a specific task we want to do. Let's say extract data from API and then transform and then load to the database. That 3 job could be the task, and dependencies are the order of execution. You're gonna execute task 1 first, and then task 3 second, and later execute task 2. And then schedule means basically scheduler. How often you're gonna run this dags? Let's dive into my dag, the libraries, and load.env, the function named get data and transform calls the open API, transform it to the pandas data frame, send it to next task. The second function is load data. Load data from specific task. You're gonna call Postgres hook and define insert query, and using the data you got from previous task, you send the query using the parameter to the Postgres. After that, you define the default argument. Using this argument, you define the DAG here. You give a name of DAG, give a default argument, you specify it here. I think most important argument is this one. You need to specify the schedule interval. And within the DAG, you need to specify the task using the Python operator. I do not know much about operator. It is a class that specifying the task. Instance of the operator is the task. Define the task ID, and you're gonna define the callback function, and it calls the function I introduced you earlier. When we are define task 1, the task 1 will generating this function, and after that you define the second task using Postgres operator. You need to specify a Postgres connection ID and SQL query, which means you're creating table if not the table exists. And task 3, it calls load data function, insert the query to the Postgres database. After you define 3 tasks, and then you need to specify the dependencies, which means you need to define the order of execution. So that is the simple DAG I created. I need to copy this code, create one file in the EC2 server. Let's so env cd airflow ls. When you first install airflow on EC2, directory named DAG does not exist. mkdir dags I already created, so I will not do anything. So came to the dags directory, and we can create one Python file. We can give a weather.py. Once we create file, we copy all the contents and paste it, and rq and see whether it is created. The file created. Before we running the DAG, we need to make sure that all the libraries are installed correctly. Pip list. Actually, if you first install Airflow on EC2, pandas does not exist. I personally installed pandas package in here. Also python.env as well. Yeah, so once you installed all the library to run the DAG, and we can go to the Airflow UI, you can see the name of DAG we just created. And when go inside, the DAG we just created is scheduled. We failed. I don't know what happened, but the first time was failed due to the JSON decoding error, and then second time the task run succeed. Task 2 and task 3 success. So when we go to the debugger, and we can see the new table called weather. So new data loaded here. Before finish, go to admin and connections, and you need to create one connection ID as weather connection, and connection type as Postgres, as we are loading the data to Postgres, and host should be localhost, and database name is Airflow, login user ID is Airflow, and password, and port should be 5432 as default port for Postgres. Once we done and we save, the DAG will run as normal. So that's it. And if you like the video, please subscribe, like, wait for the next video. Bye.